And I'm going to demonstrate to you right now, in very simple terms, that you can create infinities in the confine of a finite boundary. That these are not opposite concepts, but they actually are complementary. There is infinities to create finite boundaries, and there's finite boundaries to create infinities. And in order to demonstrate that, I'm going to use a very simple initial graphic. Although this graphic is simple, it is still absolutely accurate to the geometry that we will see throughout the day today. It's not something in left field. It's something that's very important. So here we're going to do this. We're going to generate a finite boundary we're going to call a circle here. And this circle could be a 3D sphere that contains a very specific space. And in that sphere, or in that circle, we're going to put a triangle, an equilateral triangle. Now, the universe is polarized. And the reason why things are polarized is because they spin. Okay, things in the universe are polarized because they spin. And angular momentum creates shafts of rotation that generates polarity. So if you have polarity, then you can accurately have a reverse triangle in that sphere or in that circle. Now, right away, we have one of the most common ancient symbols that we find all around the world. Called the Star of David, or the Seal of Solomon, or the six-pointed star. We'll talk about this later on in the presentation, but just take notice of it. Now we can continue to add triangles. And now we get smaller stars, baby stars of David. Okay, baby six-pointed stars. We can continue to add other resolution of stars by adding more triangles. Again, smaller stars of David. Every time we create a new resolution, we can define a very specific boundary. This is very important. And here we find a third boundary, so smaller and smaller sphere. We can continue to make smaller and smaller resolution of this geometry. And in fact, if I give this to my computer as a computer code, and I got it to make geometries maybe 5 resolution deep, and then zoom in, and then go 5 resolution deep again, and then zoom in, and then keep doing that, it would continue to do that to infinity. As long as the computer had power and chips would keep working in there, it would continue to make boundaries for thousands of years. However, I would never, ever, ever exceed the first boundary that I've set for myself. Within a finite system, I've demonstrated to you right now that you can create infinite numbers of division. Infinite numbers of sets of information. In a boundary is the possibility of infinite division. And thus, infinities and finite structures are complementary. Why is this important? Well, if you were taking these principles and applying them to yourself, you could start to visualize, you could start to imagine, you could start to experience that maybe within the confine of the finite structure that you're in, is the potential of infinite division, the potential of infinite amount of information. Philosophically, that has a very powerful impact on someone's consciousness. It just happens to be very similar to what many of the masters that have walked the earth have talked about. That within is God, the kingdom of heaven, infinite boundaries, and so on, or infinite potential, and so on. It definitely has an impact on science. Why does it? Well, I'll give you an example. When we discovered biological cells, we had microscopes that were at the maximum of the power of amplification that we could get at the time, and we thought, my God, this stuff is so small, it's gotta be the smallest thing that the universe does. And then we discovered an atom. And there's billions of atoms in every cell. That is extremely small. And we thought, oh, that's gotta be the smallest thing the universe does. And then we discovered protons and neutrons in the center of the atom. We discovered the nuclei of an atom, and we thought, that is so small. That's gotta be the smallest thing the universe does. And then quarks and so on. And what I'm saying here is that every time we find a new boundary, we think, that's it. We found the fundamental structure of creation. The universe goes to that size and then quits. That's it. I'm done. I'm not going smaller. This is way small enough. We did exactly the same thing in the other direction. Right? We thought, at first we thought the Earth was the biggest thing, and then we thought the solar system was the biggest thing. Then we found galaxies. Oh my God! That's gotta be the biggest thing. Right? And then we found superclusters and so on. Now we're at universal size and we think, okay, that's it. It stops there. Right? Well, what if it doesn't apply to the universal size and so on? The model of our universe at this point, and correct me if I'm wrong, is that the universe is expanding like a balloon. And I opened the book on page 219 and I pulled it out and I said, here's the picture of what we believe the universe is doing right now. It's expanding like a balloon, and the balloon has little pennies glued to it. And the pennies represents galaxies. That's the standard model. And the galaxies are moving away from each other as the balloon expands. And everybody's like, yes, Nassim. Where are you going with this kind of deal? Like, if you don't know this, go back and study, come back in a few years. And at one point, I'm saying, well, okay, I understand this principle. However, I have a question. Out of all these equations everywhere, what I want to know is where is the equation that represents who's this guy? And the whole room became really silent. And I could see that in the look of the students and the other physicists that there was a look of despair and stress because sweat was a little bit beading. And I could tell that they got worried because they thought, oh my God, this guy, he might just start talking about God. And we're at Georgia Tech in the physics department. We can't do that. And I reassured them very quickly. I started to draw and I said, well, let's draw the rest of the guy. And what I'm trying to point out here is that in order for the balloon to expand, then the lungs of the person that's blowing into it have to contract. For every action, there's an equal and opposite reaction. Okay? One of the first laws of physics. So if our universe is expanding, then there must be something contracting. There must be some compression happening in order to get expansion. There must be a feedback between the expansion and the contraction. And that was my first clue to the relationship between the gravitational field and the electromagnetic radiation. And as well, it applied to my experience in life, because really this is all based on my experience in life. When I was 11, I started meditating. My family came in contact with a young master of meditation that was 14 years old, and I was 11. And he taught me how to meditate, and when I meditated, it felt like I was turning my senses inwards and going towards the center of my existence. I was going towards the middle of my being. And I came, out of that, I found a logic in which there was an internal universe and an external universe. There was something going in and something going out, and the two generated boundaries. And that boundary is what we experience as reality. The thing is that in our society, the tendency is to spend a lot of time analyzing what's out and very little time analyzing what's in. Not only in our, social norms, but as well in our physics and the way we do things. We explode things. That's how we build technology. Our concept of advanced technology is to put a bunch of fuel in a cylinder, put a bunch of people on volunteers on top, and light the bottom and see if they survive the experience, It's all based on expansion, on explosion, on radiation. Very little is based on contraction, on going towards the center, on implosion. And to me, there had to be a direct relationship. So I was really... But he knew something about atoms. He said, there's one thing we know about atoms, that they're made out of 99.99999% space. And that kind of blew my mind. I was like, wait a minute. So what we see as creation, all the things we see, are mostly made out of space. But they don't feel very spacious. I mean, it's pretty solid. But what's going on is that there's all these fields interacting, and they don't necessarily are in perfect resonance, and they make boundaries and so on. And so it feels like it's solid, but it's mostly space. It's basically a field dividing the vacuum. And I thought, oh, there it is. It started to match. And that was my first chemistry class. It started to make sense. Oh, yeah. Maybe we should look at the vacuum. Maybe it's the vacuum, what we call space, that has the key to creation. And the space divides itself, and then we see it as finite boundaries. Maybe the space is the infinity, and the boundary is the finite structure. The field is the finite structure. I started to see it in my head. I got very excited.